Hello students, how are you? I am Tejesh from 2Pi Academy. Today's video is about types of matrices. In this section, we'll discuss the various types of matrices there are. The first type of matrix is a column matrix. Now you can just understand this from the name, right? A column matrix is a matrix which have only a single column. Like for example, the matrix -1, 0, 3. It have a single column, right? And then the matrix 2, pi. Once again, matrices can contain any types of numbers, even irrational numbers like pi, right? And finally, 2, 0, 2, 2. It have one column and 4 rows, right? These three are column matrices. Now, what are the orders of these matrices? First matrix have 3 rows and 1 column, right? The order is nothing but number of rows by number of columns. So the order of this is 3 by 1. And the second matrix, it have 2 rows and 1 column. So order is 2 by 1, right? Number of rows by number of columns. And finally 2, 0, 2, 2. This matrix have 4 rows and 1 column, right? The order is nothing but 4 by 1. Number of rows by number of columns. So generally you can say that the order is m by 1. There will be m rows and only 1 column, right? The second type of matrix is the row matrix. This is same as the column matrix, but here we only have a single row. Like for example, 1, 2, 3. It have 1 row and 3 columns, right? So it is a row matrix. And 4, 1 by 3. It have 2 columns and 1 row. So it is also a row matrix. And finally, -1, 5, 2, 0. This also have a single row but 4 columns. Now once again, what are the orders of these? The first one have 1 row and 3 columns, so 1 by 3. And the second matrix have 1 row and 2 columns, 1 by 2, number of rows by number of columns. And the last matrix is a 1 by 4 matrix, right? There is 1 row and 4 columns. So generally you can say that the order of a row matrix is 1 by n. It only have single row, right? Order is nothing but number of rows by number of columns. So it will be 1 by n, any number of columns. The third type of matrix is the square matrix. Now, how do you find a square? Square have all sides equal, right? Even in the matrices, square matrix have the same concept. A square matrix have equal number of rows and columns. Like if there are 3 rows, there will be 3 columns. If there are 2 rows, there will be 2 columns, etc. This number of rows will be equal to number of columns. Some of the examples of square matrices are the matrix 3. It is a 1 by 1 matrix, right? It have 1 row and 1 column. And then the matrix -1, 5, 3, 0. This matrix have 2 rows and 2 columns. Number of rows is equal to number of columns, right? And finally 1, 2, -1, 0, √5, 3, -4, 2, 0. This matrix have 3 rows and 3 columns, right? So now what are the orders of this? The first matrix is a 1 by 1 matrix, number of rows by number of columns. And the second matrix is a 2 by 2 matrix, 2 rows by 2 columns. And the third matrix is a 3 by 3 matrix, 3 rows by 3 columns. So you can observe a pattern, right? The order will be of the form m by m. Now generally, a square matrix of order m by m is called as a square matrix of order m. No need to tell twice if it is one number, right? So we'll simply call it square matrix of order m. Before continuing the video, please subscribe to the channel and hit the bell icon so that you can get notified for every future upload. The fourth type of matrix is the diagonal matrix. A diagonal matrix is a square matrix where all the non-diagonal elements are 0. But first, what are diagonal elements? Diagonal elements are the elements a, I, j such that I is equal to j. Means the row number of the element will be equal to the column number, like a11, a22, a33 and so on. I and j will be equal. So if a is equal to matrix a, I, j, n by n is a diagonal matrix, then we can say that a, I, j is equal to 0 when I is not equal to j. Non-diagonal elements are 0, right? Diagonal elements means I is equal to j. So when I is not equal to j, aij is equal to 0. Some examples of diagonal matrices are the matrix -2, is a 1 by 1 matrix, right? It only have a single element and that element is a diagonal element. So technically all the non-diagonal elements are 0, right? There are no non-diagonal elements itself. And then 2, 0, 0, pi. Now here there are two diagonal elements, right? The first row first element, which is 2, and second row second element. And all the remaining elements are 0, right? So all the non-diagonal elements are 0. It is a diagonal matrix. And then -1, 0, 0, 0, 5, 0, 0, 0, 2. It is a 3 by 3 matrix. And A11, that is first row first element is -1, second row second element is 5, and third row third element is 2. And remaining all the elements are 0. So it is also a diagonal matrix. And the fifth type of matrix is a scalar matrix. A scalar matrix is nothing but a diagonal matrix whose diagonal elements are all equal. So you can say that if B is equal to matrix Bij n by n is a scalar matrix, then it means that Bij will be 0 when I is not equal to j, the non-diagonal elements, and k when I is equal to j, means the diagonal elements. K can be any constant. Now some examples of scalar matrices are root 5, which is a 1 by 1 matrix, and the same thing we have said before applies here too, right? It only have one element which is a diagonal element. So all the diagonal elements can be considered equal, right? And then we have 3, 0, 0, 3. The diagonal elements are all 3. And finally -1, 0, 0, 0, -1, 0, 0, 0, -1. It have 3 rows and 3 columns, 3 by 3 matrix, and all the diagonal elements are -1, right? So it is a scalar matrix. The sixth type of matrix is the identity matrix. Identity matrix is nothing but a scalar matrix whose diagonal elements are all 1. In scalar matrix, diagonal elements are all equal, right? But here all the diagonal elements will be 1, can't be any other number. So if C is equal to Cij n by n is an identity matrix, then it means that Cij is equal to 0 when I is not equal to j, means all the non-diagonal elements, and 1 when I is equal to j, which means the diagonal elements. Like for example 1, 1, 0, 0, 1 is a 2 by 2 matrix, right? And all the diagonal elements are 1. And 1, 0, 0, 0, 1, 0, 0, 0, 1 is a 3 by 3 matrix in which all the non-diagonals are 0, right? And diagonals are all 1. So it is also an identity matrix. Now generally an identity matrix of order n is denoted by In. Like the first matrix is 1 by 1 matrix, right? So its order is 1. So it is denoted by I1. The second matrix is 2 by 2 matrix, right? So its order is 2. So it is denoted by I2. And finally the third matrix is a 3 by 3 matrix, order 3. So it is denoted by I3. And finally the last type of matrix is the zero matrix. Zero matrix is nothing but a matrix whose elements are all 0. Every element will be 0. This is also called as a null matrix. And a zero matrix is usually denoted by capital letter O because it looks like 0, right? Some examples of zero matrices are 0 is a 1 by 1 matrix, 6 zeros, 2 by 3 matrix, even more zeros. You can identify zero matrix very easily, right? All the elements will be 0, no other element. These are some of the examples of zero matrix. Now let's have a quick mind map of all the types of matrices we have discussed. There are a total of 7 types of matrices, starting with column matrix, which only have single column, row matrix, only a single row, square matrix, same number of rows and columns, diagonal matrix, all the non-diagonal elements are 0, scalar matrix, all the non-diagonal elements are 0 and diagonal elements are all equal. In identity matrix, non-diagonal elements are 0 and diagonal elements are 1. And finally 0 or null matrix, all the elements are 0.